So today we are going to move on and be discussing measuring angles. This little guy here, our protractor, can come in handy when we're doing certain things on this. So he'll show back up later. Don't need him right now though. Okay, as you can notice on my sheet here, it says right away, add quadrant pick here. Well, let me explain what that means here. Let's scooch this over a bit. And we can take a peek. Every time you're graphing with something, okay, you've got 4 quadrants that you're working with. So there's a couple of different things we have to keep track of with this. One of them is actually the numbers of the quadrants. And if it's been a while, quadrants start in the upper right-hand corner and kind of go in a C shape. So 1, 2, 3, 4. And go around that way. So sometimes you'll be just asked something as simple as what quadrant is something in. Like, why would I need to know that on these? We're doing trig, I thought. And we are. But here's where that comes in handy. Because these quadrants also can be divided up into the quadrants where we find positive values for our trig functions. Okay. So what we're going to do here in a moment is we're going to label which ones of my trig functions are positive in which place, and kind of how that's going to affect us. So here's how this goes. In my first quadrant, all my trig functions are positive. So if you ever have a value that you're plugging into the calculator or using a chart to find, and it's between 0 and 90 degrees, it's going to come out positive, or it should. Okay. If I move to the second quadrant, my sine function values would be positive. So that'd be between 90 and 180. So you're like, oh, so does that mean anywhere between 0 and 180, sine would be positive because it's included in the all, and it's also included here, and that would be true. When I move down to my third quadrant, that's where tangent's going to be positive. So that'd be any values between 180 and 270. And then we only got one left, and that's cosine. Bless you. And cosine would be positive between 270 and back to the beginning at 360. If it's not positive in that quadrant, so that's a good question, you know, what about the negative part? Well, if sine is positive here, the other two aren't. So tangent would be negative in quadrant 2, and so would cosine. Or if we get to quadrant 3, tangent's positive, but sine and cosine would both be negative. So if it's not positive in that place, it's going to be negative. You'll see as we're poking them in on the calculator how this kind of makes a connection with that. Well, we'll unconfuse you as we go along. So, okay, use a calculator to evaluate the following, use degree mode. So we're going to pop up our calculator here. And again, we want to make sure it's in degree mode because we're coming close to that point where my classes are going to be in different modes. So we got to make sure we're using the right one. So as soon as you pop one open, if it's in here in class, always make sure you go to mode. We don't want it in radian. That would be bad. That's how you start getting answers that are different than everybody else. So we go to degree. And then we basically are going to let the calculator help us out. So we're going to hit cosine of 90. Okay. We hit enter. 0. That's kind of weird, but okay. And we'll discuss some of the ones that end up on an axis as we go along here. Okay. Number 2. Let me slide over. Sine of 146. You're like, ooh, is it supposed to be like all decimally like that? Yeah, and typically we go to 2 decimal places. Okay, so we get that in there. And again, sine of 146. Where does 146 fall? It falls here between 90 and 180. Sine's positive in this quadrant. But when I do the next one, cosine of 150, I get a negative. Why do I get a negative?
Can you get a negative?
Because in quadrant 2, the only trig function that's positive is sine. Cosine isn't sine, so it's a negative. Okay, so sometimes maybe you're just asked, is it positive or negative without using the calculator? Can you figure it out? And that's how I do it. Sine of 150. Again, falls in the sine quadrant, so I know it's going to be positive. But if I'm just using the calculator, why do I need to know? Because there are some parts sometimes that the calculator may not be your best bet. I can type negative angles in here. Now this will be interesting. You're like, now wait a minute. So how is cosine of negative 65 a positive? Well, first of all, what the heck's a negative angle? I haven't seen that before. We'll talk in a minute how this positive and negative thing goes, but as I rotate around, okay, counterclockwise, I get 0, 90, 180, 270. If I start going backwards, okay, if I start going clockwise, they all become negative. So it goes from 0 to negative 90 to negative 180 and moves around that way. But we're going to start doing that in a minute. It just kind of gives you a little preview of it. And then the same thing with my sine. Okay, sine of negative 60 would end up down here. Cosine's positive down here. That's how this ended up as a negative. Okay, but it just kind of lets you see how this works a little bit. Nothing too bad, but it'll make more sense once we actually start doing the drawing here in a minute, I think. Okay, so we get done playing with the calculator. Okay, now what? Well, now we're going to start getting into a few of the concepts that go along here. So, when an angle is in what's called standard position, it's an angle that has a vertex at the origin and one ray is on the positive x-axis. So for instance, this picture I've got right below here would be an angle that's in standard position. Its vertex is at the origin, and one of its sides is on the x-axis. Okay, that's what it would look like. So then the ray on the x-axis, this side, as you can see from the picture, is called the initial side. All the angles we're going to be drawing are going to start on the initial side. They're going to start on the positive side of the x-axis. And then my other side is where my angle ends, which is why it's called the terminal or ending side. And then we'll always measure that angle from the initial side to the terminal side. And the direction that we do it in will determine whether it's positive or negative. So speaking of positive or negative, and we'll kind of keep everything in our screen here. Okay, the measure of an angle is positive when the rotation from our initial side is counterclockwise. In other words, if I start at my initial side and I follow like this arrow does this way, that tells me it's going to become a positive angle. And when I measure it, my answer will be a positive value. The angle measure will. However, if I'm looking for a negative angle, I'm going to start from that same initial side on the x-axis, but instead of going counterclockwise, I'm going to go clockwise. And that makes the angle negative. So that's the biggest thing I got to remember, this whole positive negative thing, which direction my arrow is going to be going to say, is it positive or is it negative? So when we go to sketch, okay, and I'm actually going to break out my handy dandy little protractor guy here now. It also is a nice way of using as a straight edge. So I'm going to make myself a couple of axes here. And so when I go to draw an angle, here's going to be the key to this. I'm going to go ahead, that little circle that's down here at the bottom, I want to line that up with the origin. And I want to line up those other two straight lines that you see with my axes. Once I've done that, and I try to keep my glare down as best as I can here, now since I'm looking for a 45-degree angle, I'm going to look on the inside of the chart until I see about where the 45 is. Now here's the one disadvantage of these clear ones. I can't just stick my pencil and start drawing because, well, it's just going to draw in here. So I'm going to sort of hover my pen or pencil over where that 45 would be, right in between the 40 and 50. Slide this out of the way, put my little dot in, and then connect that point to the origin. And since it's a positive 45 degrees that I'm drawing, I want to draw my arrow counterclockwise. Sure. What about it?
How long are we going to be like needing to use
On and off during the trig unit. Yeah, you'll probably want to keep these in a safe spot, whether it's like a purse, a billfold, just somewhere where it's not going to get lost. Because I have a few extras, but I can't like be replacing them every single day. So when we're doing this, it's that whole positive, negative, which direction you go thing is the thing that's going to cause probably the most issues, I would imagine. So you're like, okay, so this is negative 90. So when we go to negative 90, and we talked about this a little before, but we didn't put it on there. When I'm using negative degree measures, they go the opposite way that I was doing them before. Where before we went 0, 90, 180, 270. When it's negative, it goes clockwise. It goes the opposite. You're like, well, this one's kind of weird. Because like 90's right there, and that's what I'm supposed to draw. So what's up with that? 270. Because each quadrant is another 90 degrees. So here's still going to be my initial side. And since negative 90 is right on the axis, I'll just go ahead and color on the axis and draw my arrow in. But negative angles are always going to go clockwise, and positives are always going to go counter. That's why we got all of the kind of examples to help at the start while we're getting used to it. Getting used to it. Again, I look always first to see whether it's positive or negative. If it's positive, I know they're going to go around counterclockwise, so I can mark my angles down to help me a bit, get some guidance. Then I look and I'm like, okay, 170. Get this guy lined up. And again, when it's up here, I'm just going to work my way around till I get to the 170 here. Okay, so it's this line. Just going to hover. Make my dot. Connect it back. And I've got my 170 degree angle. And again, it'll take some practice, especially when we start getting into some bigger angles and stuff. But it's not anything that's going to be impossible to be dealing with. Okay. All right. Now we're going to combine this drawing of our angles with something we were working on last week with our special rights. So we're going to be given a point, like we are here. Then we're going to identify the angle that's at the origin. We'll figure that out in a minute. We'll chat about that. We'll get our 30, 60, 90 and our 45, 45, 90s back up here. And then we're going to determine the angle. So my first job is wherever that ray is, I want to make a triangle out of it by reconnecting it to the x-axis. Okay, and we'll even draw that up here. If I take that ray and I connect it to the x-axis, that's going to make a right triangle. Now the question at that point is going to be, is it a 45, 45, 90? Or is it a 30, 60, 90? Well, how do I know? So here's how we're going to figure it out. Just a reminder. When we were talking about special right triangles, we said before with my 45, 45, 90, it was always x, x, x square root of 2, because again, everything with trig especially has a lot of patterns involved. In our 30, 60, 90, across from 30 was always our x. Across from 60 was our x square root of 3. And across from our right angle was 2x. So my job is going to be to look at the pattern that's here and see if I can figure out which one it would go with. But there's usually a pretty good clue on how this is going to work. So you're like, okay, but they didn't really give me any sides. They just gave me this number down here and a point. How am I supposed to use that? Well, let's zoom in a little more here. Okay, because I want to be able to see my triangles here and see what's going on. If this is a coordinate point, this is my x value, which means the side on the x-axis is that value. And this is my y value, which means the y side of my triangle, the up and down side, is going to be my y. So it's my job to figure out what type of triangle this is, but I'm in luck. I see this square root of 3, which tells me, ooh, it's going to be one of these. So if it's going to be one of these, the square root of 3 side, if I'm looking at it opposite-wise, okay, and I'll even draw this bigger over here, because I know sometimes this can be tough to see all these things. So I'm just going to redraw it kind of in jumbo mode over here. Uh-oh, I know, I've made it so big that I can't even see it anymore. Okay, there, now we're on. So what I'm trying to figure out is, and I forgot my square root on there, I'm like, ooh, which side's the one that's opposite of the square root of 3? The 60 is. Okay, which side would be opposite the -1 or the one that doesn't have a radical? The 30 would be. Okay, and I sort of figured this out based on the information that I have. So now that I know that, I know that this angle right here, and that's the one that I'm looking for, is the 60-degree angle. Now, does that give me the answer in total? Not quite, but we're almost there. Because now I can look and I can say, okay, if I'm trying to figure this out, because this is what I want to know. This is my mystery angle. So what I'm going to do is I'm going to say, okay, well, I'm going this way, so it's those darn negatives. So I know from here to here is 90, or -90. Can I figure out what this little piece is? Shh. So if this whole quadrant here is 90, good. And I know this piece is 60. 60 plus what is 90? This little piece is 30. And I just add them up. So you can start to see the connection of where, ooh, if I understand the special right triangle at least enough to know the one with the square root of 3 is the 30, 60, 90, and the one with the square root of 2 is 45, 45, 90, I might have a chance that this actually turns out okay for me. Or so I hope. So you're like, okay, that was kind of weird. Yeah, it was. I'm not even going to lie. It was. So then I get to the next one. I go, okay, connect to the x-axis. That is the mystery angle that I am looking for. So again, if you don't have enough room, which is easy enough to have happen sometimes with these, okay, we can draw a jumbo-sized one next to it here. And I look and I go, okay, my x value, so along here, is negative 2 square root of 3. My y value, or the upside, is 2. My job, figure out which one's which. Well, again, I see there's a square root of 3, so I know it's 30, 60, 90. So I know one of these is 30 and one is 60. But here's the question. Is it the top or the bottom angle that's the 60? The top one, because the square root of 3 one is always opposite of where the 60 is. Okay. The one that doesn't have the square root of 3 is always the one that's the 30. So I know this time that this guy is the 30. I know that part. So I'm like, okay, let's figure this out. It's positive because it's going counter. So again, I know this piece is 90 degrees. What's this piece going to be? If this is 30, what's left for this piece? This piece has got to be 60. So 90 plus 60 is 150. And I just kind of keep working those special right triangles to help me find out what that angle is going to be. But again, it's something we can play with. It's something that we can work on. Now we actually get to back up to something easier. So let me back out here a little bit. So it locks in here. Okay. So then, sometimes we're going to be able to go either the positive or the negative direction and end up at the same place at the end. You're like, well, is it the same measure? No. When this particular event occurs, where two angles that are in standard position have the same ending ray, the same terminal side, so going this way, I'll just let you know this part was 45, so going around this way, this particular angle was 225 degrees. But if I do that same thing, but I go counterclockwise, this is negative 90 and negative, oops, I should have drawn that over here, it's negative 135. So to find coterminal angles, you take whatever angle measure you get and you can add or subtract 360, because 360 is what? A whole circle, a whole rotation. So to find an angle that's coterminal, I'm either going to have to add or subtract 360. Well, since 390 is already bigger than that, I could minus 360 and find a coterminal angle. If I wanted to find another coterminal angle, I could add 360. It'd be a really, really big angle, but I could do it. Or if it's a negative, if I subtract, that's going to be really big. So if I add 360, punch that up on my calculator. Whoops, 150, Mr. H. Okay, that would be coterminal. If I drew a negative 210 degree angle, and then I drew a 150 degree angle, they'd end at the same place. It'd just be the arrows would be going different directions. And then, whoa, 1105, okay. All right, let's minus 360. Let's see what happens with that first. Okay, now, the 745 would be a coterminal angle, but we're being asked to find one between 0 and 360, so we're not there yet. So we're going to minus 360 again. Oh, close. And another coterminal angle, but still not where I want to be. So one last time. But again, all three of those are coterminal. It just so happens that with our restriction this time, we had to do it an extra couple of times here. Otherwise, that's about it. And then the last question, this is more like the ones you'd be dealing with. Determine whether negative 693 and 27 are coterminal. Like, well, how do I do that? Well, let's take the negative 693. And let's add 360, and let's see what happens here. Okay, that's negative 333. Now let's see if we add 360 again. If we end up going past the 27, well, then we're kind of out of luck. But if I add another 360 and I get the other angle by adding or subtracting 360 as I go along, then they're coterminal. Now if I'd have added 360 and it would have said, or this and 17 coterminal. Well, no, that wouldn't work because that doesn't equal that. So if I can add a 360 or subtract 360 to get from one to the other, they're coterminal with each other. And I think I saved the easiest thing for last. I hope I did at least. That wasn't bad. But let's see if I can make it a little easier. Okay. Now, this unit circle, here's a positive for you. My other classes, they have to memorize it. You guys don't. Okay, you guys, whenever you need the unit circle, will have it in front of you, ready to go. So it still has its challenges. I agree. So, when we're looking for the missing side lengths, okay, we're going to do our 45, 45, 90. Now again, 45, 45, 90. How does this work? It's x, x, x square root of 2. So just like we did when we were doing this before, I've got to know how to get this value. But we talked about the shortcut with this. With the square root of 2, you take the 1, you cut it in half, which would be a half, right? And slap a square root of 2 on it. Half of this value, if you're given the hypotenuse, and slap a square root of 2. And since these are the same value, that would give me my answer. And this also could be written as the square root of 2 over 2. They're the same thing. Okay, so you can write it either way, though. They're the same value. I can't tell you it's wrong. Okay. And then with my other one, again, 30 across from 60, across from my right angle is my hypotenuse. So if I'm given this, again, I'm like, well, if 1 equals 2x, x would equal a half. So this would be 1/2, because that's just x. And then this would be 1/2 times the square root of 3, or the square root of 3 over 2. Either one of them works. Again, it's just working with the pattern that's involved. And that's where our last thing for today comes into play. The unit circle does all of these things for us. So maybe it'll be something here at the end we can take a liking to. Okay. The unit circle is a circle of radius 1, centered at the origin. So all of this craziness that you see here basically is taking all of your special right triangles and putting them into a circle with values for you, which is kind of nice. So when I'm asking you to find something of an answer, instead of putting it in the calculator or calculating it with a special right triangle, you can refer to the unit circle. So when you're doing these are all coordinates. The x value of every coordinate all the way around is the cosine value at that value. It's the same thing you would get if you typed it into the calculator. So like for instance, if I went to the calculator and I typed in, let's find one here. If I type in cosine of 120. Cosine of 120 is negative 0.5. Well, look at that, negative 1/2. What a coincidence. And they work that way. And then my sine is going to be the value of the y all the way around. Okay, so always cosine and then sine, just like they come in the alphabet. C comes before S does. And you'll really get used to what some of these decimals are. So let me explain what I mean by that. If you get used to some things, so let's say we do, I don't know, let's do cosine of 30. Okay? We'll jot a couple things down here. Square root of 3 over 2 is 0.87. And you see around that circle, there's a lot of square root of 3 over 2's. So if you see that on the calculator somewhere, you'll know what that value is. What about if I have, let's see, sine of 45? Because I see that's square root of 2 over 2. Okay. Square root of 2 over 2 is 0.71. So whenever you see those decimals, you know, yeah, I'm doing the right thing, because besides 1/2, that's the only other thing that happens all the way around the circle. So if you're asked to use the unit circle to find a value, okay, evaluate using the unit circle. Sine of 90, 90, y value, 1, boom. I get the same answer with the calculator, but shoot, this is faster. Cosine of 270, cosine, 0. All based on special right triangles. Sine of negative 90. Remember, negatives, I'm coming this way. Remember, when we're going around, the negatives are going the opposite way. So like this would be negative 30, negative 45, negative 60. I'm just working my way back around with those. It's the same values going this way, except the exact opposite. And that'd be tricky to put into a circle, so we typically just put them in going the positive way. Okay, cosine of 225. Cosine, negative square root of 2 over 2. Sine of 60. Square root of 3 over 2. And you even notice as you're going through, the whole positive negative thing is all there for you as well. And then cosine of negative 60, remember, so this is like negative 30, negative 45, negative 60. Cosine is 1/2. Now you're like, what if I forget that with the negative thing? How can I figure out where it's at? It's a coincidence on that particular one because cosine in the first and fourth quadrant's always positive. Yeah, that's why that happened to work that time. It wouldn't work every time, though, on going the opposite direction. Okay? So again, it's going to be a challenge this first time you're doing it to sit, keep this by you, and fight through some. We're going to spend today doing it. Tomorrow, we're not going to do anything new. It's going to be this again. I'm going to have a video of going back through this stuff again to try and make sure we're feeling okay with it. And if we need to talk some more on Wednesday about it, we will. We'll do what we got to do. Okay? But try this. Give it a go. Don't just shut down. Worst case scenario, take a picture of the couple of pages that the problems are on so you can do that so you're not coming in tomorrow fresh wondering why you don't remember it because it's brand new to you again.